Hi, welcome back to Microsemi Space Forum 2017. I'm Chris Hart, Director of Marketing for DPG's Aerospace Products. And I'm going to start off with just a couple of reminders here. I'm going to present the power product overview, and then Brian's going to come in. He's our Senior Director of Applications, and he's going to show you how to put our power solutions around an RTG4 FPGA. So with that, if there's any questions, please put them on the chat window, and we'll address them at the end of the presentation. So I'm going to discuss today our DPG product executive overview. What that consists of is that we have power products, power solutions, we have discretes, we have basically the full solution to build up a power supply in the space satellite. I also want to go through our non-isolated point of load and hybrid capabilities. What they are is how we power our FPGAs directly and how we enable smaller solutions around the power section of your satellite. We'll also discuss some of our isolated bus converters, as well as how they support the critical satellite power rails in your system. And then finally, I'll go through some critical swap improvements that we're looking at for next generation power solutions. So as you're considering your design for a power supply, one of the most critical features of that is selecting a high-quality component. With that, our suppliers typically look at 19500 certified components. We are one of the world's largest suppliers of that. We have over 59% of the DLA certified discretes on the QPL. A more impressive feat within that is that we actually have, and that consists of various quality levels as much as packages as well. But we actually are certified on 75% of the slash sheets. So that pretty much means if you come to us for a discrete solution, we're going to have an option available for you. Additionally, as we're designing, we're seeing more and more collaboration with ESA, NASA, across worldwide space market. The majority of our space components are classified as EAR 99 for the export control code, leveraging that collaboration across the worldwide space market. Within our group, we have over 40 years of power supply expertise on surface mount designs. This expertise really allows you to assist your internal design capability within your system level solution. So what I'm trying to get across there is some of our designers are very limited. We have the capability within Microsemi to actually design an end-to-end power solution, as well as providing you the discrete components to design it yourself. In addition, one of the critical areas that we focus on is packaging. As silicon is reaching its maximum capability within power solutions, the limiting factor is becoming more and more the packaging of our components. We focus heavily on the discrete as well as the hybrid packaging and our SMT solutions. This allows us to offer a end-to-end solution that's optimized for size, weight, and power. As we move forward into the new space market, there's a lot of constellations being considered in high volume. We're looking at new space flow that leverages our non-hermetic portfolio that offers a custom solution for your systems. As we move forward, we want to continue to be a leader in radiation-hardened solutions and technology innovation. This will allow us to lead the way as we proceed forward in next-generation topologies. Now I'm moving forward into the satellite power system. So if you look at the satellite power system, Ken showed a diagram early on that really showed the background of where the FPGAs are situated. If you look at this from a power perspective, you can see the DC to DC power solution is a roadblock. If it's becoming more and more of a roadblock for our design community. The FPGAs are requiring a lot lower voltage and a lot higher current. So as we're talking to designers, the power is becoming more and more of a bottleneck and also a critical part of the fault-tolerant architecture. As I show here in the diagram, the system power bus is supplying power to both the payload, the system bus, the attitude, determination, and control, the communications, the command and data handling systems. All those function from an isolated DC to DC converter. So from those DC to DC converters, there's a single point of failure within the isolated topology, and that's the reason that we offer isolated solutions that isolate it from the system power bus. That isolation provides critical fault tolerance protection for our satellite. So when we look at those solutions, radiation performance is also very critical. So is efficiency, so is size, weight, and power. And as you go down the system from the DC to DC, this architecture is distributed. So there's an isolated DC to DC. And then we also offer point of load solutions right next to the FPGA for all these different subsystems. Moving forward, I'll just show you a kind of an overview of the different products we offer. Our DC to DC solutions that I mentioned in the isolated topologies, our leading product is the SA50 family. It has over 25 years of flight hours with 0 failures and thousands of hours of worst case analysis. This is really critical to our customer base, and we also offer variations of this to offer custom solutions and semi-custom solutions for our customers to optimize the solution that they're looking to provide for the end application. In addition, our power discretes has the largest glass diode and transistor family in the market, enabling our customers to have a broad selection of discrete components as they design their own power supplies. One of the things I mentioned around limiting factors of point of load power is size. So our MHP 8565A is one of the smallest solutions in the market. If you look at the I/O rails on an RTG4, the I/O currents are approximately a half amp on the majority of the I/O rails. This allows an optimal solution for the I/O rails, and then we're looking at higher current solutions for the core power supply. Our electromagnetic relays are used in hundreds of satellites across the world and thousands of applications. As I move forward, I just wanted to kind of give you a little bit of an overview of our different technologies that we offer. The majority of our customers, when they're looking at power supplies, they look at surface mount, and they also look at hybrid technology. We're one of the few vendors in the market that can offer both, enabling our customers an opportunity to look at the different trade-offs between each version of power technology. Within the SMT world, you have automated pick and place. Hybrid can be automated as well as manual, both offering a very good assembly process. The die attach is critical. There's a solder connection within SMT offering a little bit higher reliability connection as well as a wire bond connection within the hybrid. If you look at the hybrid technology, you can shrink it. There's a qualification available for that we supply, 38534. The qualification on our SMT boards is the same flow as the rest of your design in the market. So in summary, our standard hybrids are available for quick lead times as well as our SMT solutions. The unique advantage of an SMT solution is that we can offer quick turn customization without the upfront NRE cost of a substrate design for a hybrid. This may offer you a little bit bigger solution, but give you a faster solution to market. Now, the hybrid solutions will give you the most integration in your design as well as the best efficiency. But the combination of these provide a unique capability within the market to offer you both options for your satellite design. Now, going into a little bit more detail on our hybrid capabilities. We offer both catalog and custom design supporting both the space and the defense market. Our facility certification is 38534 up to class H and K, the highest certification within the 38534 standard. The design capabilities within our team is focused on worst case analysis, the substrate design, mechanical thermal design, and the power module as well. The custom design capability or build to print, we offer both of those. We offer total parts management, a hybrid assembly and die attach, as well as the full hermetic or non-hermetic assembly options. We have the capability within house to do full vibration and shock testing, enabling a full end-to-end solution for a power supply. I show you a couple of pictures here on the right, which is a ceramic flat pack design as well as a substrate, as well as a couple other unique power custom products that we offer in the market. Now I'm going to move forward into our MHP 85 XX 85 family. These are point of load solutions. They're non-isolated. They provide current mode control capability. With that over voltage mode capability, which is preferred in the market due to its ease of worst case analysis and controlling stability. These solutions, which I show on the right, are being put together. Brian's going to show you a detailed overview of how this can be used to supply the RTG4 with a power solution. The 8565A is already fully qualified to an SMD RHA of 100K KRAD level. This offers you the capability to supply up to an input rail from 4.5 to 12 volts, supporting the major intermediate power rails in this system today. The unique capability there is around the solution size. The 8565A is in a unique 5-pin package, providing one of the smallest solutions out there in the market today. The limiting factor is really current, so we're proposing you place those on the low current rails, and Brian will talk to that in a little bit more detail. Now the 8564 offers a little bit higher capability of current, and we can parallel those to provide a higher level of output current. This solution has been proposed as an optimized solution for LEO orbits. The reason I'm saying that is the TID is fully rated to 100 kilorad. To enable worst case analysis to meet accuracy of 5%, the accuracy drift tolerance of our reference is about less than 1% at 50 kilorad. So I'm showing this as an optimal solution for LEO orbits with the 50 kilorad spec. The single event performance is also optimized for LEO orbit as well, showing SEE immunity up to approximately 58 MeV, looking at both destructive and non-destructive single event effects. One of the more critical ones in a power supply design is obviously the single event gate rupture and single event burnout that occurs at higher current under heavy ion. These devices have been fully tested for single event burnout gate rupture up to 85 MeV. So destructively, these devices will pass. There's some single event transient effects that are documented in our radiation report at approximately 58 MeV. This product is fully certified to 38534, offering both Class H and K availability, radiation hardness assured through DLA up to 100 kilorad, and we perform all TID testing in accordance with 883 method 1019.6. The high VN input on the 8565 or the 85 series offers a significant derating margin for your 5-volt systems. What I'm looking at here is in the market there's a lot of limitations within the 5-volt rail. Currently, a lot of integrated solutions only support 5.5 volts input. This requires you to really take risk on your 5-volt rail and control the tolerance on that pretty aggressively. Our solutions allow you to have a little bit more flexibility on your 5-volt rail, allowing a higher tolerance up to 5.5 volts. Moving forward, I showed you in the earlier slide our isolated solution coming right off the satellite bus rail. This is a detailed look of the SA50 series isolated DC to DC, which has 120 volt input capability. It can be customized for 28 volts. We have over 20 catalog offerings of the 120 volt offering for different output voltages. One of the main ones that we see used quite a bit is the 5 and plus or minus 15 volt option, which offers best-in-class efficiency. I will show that in a later slide. These have isolated outputs, providing you the isolation from ground from the bus to your payload. Has a isolated sync input, allowing you to sync the PWM converter to optimize the EMI performance of this device. And we also embed an EMI filter as well to help increase that availability. It's one of the smallest solutions in the market at 3 by 2, about a half-inch tall. One of the best advantages of this solution is the single event effects performance. If you look at this device, it's virtually single event immune to all effects up to 80 MeV, as well as providing you the option for customization for any unique requirements, unique output voltages that you need to offer. We provide this in a industry standard package that we've been providing to the market for the past 25 years. If I look at the efficiency performance of the SA50, it's best in class for an isolated topology coming off the 120 volt power rail. It's approximately 86% looking at various different loads, maximized at 25C, and this is showing the 5 volt output and the plus or minus 15. So as we move forward into the next generation power supplies, we're looking at different types of swap improvements, size, weight, and power. We see two areas that we can improve upon. One is the point of load. We can offer a smaller solution for the point of load. We're also proposing a point of module concept that we've been looking at for the past couple of years, and I'll go through that with you to show the pros and cons of that as well. So we're looking at an extension of the MHP series. This is a synchronous hybrid point of load converter. The converters that I showed you before weren't fully synchronous. So this provides a unique efficiency improvement of approximately 10% over our current solutions. We also provide on this solution input voltage up to 6.3 volts with an internal reference all the way down to 0.8. I list this device. Currently, it's got parallel operation of 180 degrees with a sync pin and internal VREF of 1.5%. That means your 1.5% reference is controlled over temperature and radiation effects. This is going to allow you significant margin for your worst case analysis for meeting a 5% end of life spec for your FPGAs. It has ultra fast transient response that actually allows you to further shrink the solution size by minimizing the amount of output capacitance on your solution. We will be integrating the inductor into this solution, allowing you to further shrink the solution. We'll provide an external compensation algorithm to allow customers to optimize the compensation externally for their different capacitive loading. External enable and input and output. This is critical for FPGA solutions that require sequencing. Fortunately, within our RTG4 family, if you hold the device in reset, you don't have to use this functionality, but for other solutions, it's available to you. It offers a 95% peak efficiency, looking at 100 kilorad RHA qualified, single event effects immune to 65 MeV. This product will be DLA certified on our 38534 facilities, offering optimal solution size as well as some capability to parallel to support higher currents. I show a preliminary block diagram on the right. If you're interested, please reach out to us for any questions as we're further developing this product. So one of the other areas I mentioned, an opportunity for size reduction, is around the entire architecture. The traditional architecture looks like I have shown here today. It's the architecture that Brian's going to be showing a detailed point of load or power solution for the RTG4, dropping from approximately 100 volts down to 5, down to point of load. Now, what could happen if you could replace that? So this is the concept that I'm going to jump into now. It's called the SB30. We've done some preliminary prototyping on this device. We're looking at getting customer feedback. I list some preliminary performances that we're looking at offering here. What we're doing here is we're leveraging the proven SA50 topologies, and we're adapting it for point of load solutions. What this allows you to do, traditional point of load solutions offer an isolation between one rail to the next. So you're not coupling from one power supply to the next. So what we've done in this is offer three individual PWM three individual outputs to provide not only input to output isolation, but also output to output isolation between the supplies, preventing noise coupling from one power rail to the other. This was also be offered in our SMT construction, offering the same radiation performance as our proven SA50 topology. Now, going into greater detail, one of the challenges with this architecture is really efficiency, and also minimizing the inductance between your point of module concept and your point of load. The reason that is critical is because the power supply is going to have to respond to the point of load solution relatively quickly. With large inductive loops, you're going to have difficulty maintaining your voltage at your power supply. So I'm just going to go through a little bit of the detail here. So what we're looking at doing, the nice part, the description here shows full MIL 461 compliance at the satellite bus with input-output isolation. We also offer excellent load step response if the inductance is minimized between there. The power distribution, each channel has individual current limits, allowing you to minimize the copper down to the point of load. With that, let me go into that a little bit more detail. So if your current limit is set really high and you have a short downstream, you have to design for worst case, maximizing your copper throughout your power design. If you're able to set these current limits of right above your design, you're able to minimize the amount of copper that you have to put downstream. So this allows our customers to really optimize their design even further. Now, the electrical block diagram of the SB30 offers, I'll go into this a little bit more detail right now. So each individual output is trimmable, adjustable to plus or minus 10%, enabling you to set these output rails just at the precise location you need for your FPGA or ASIC. We've also done a built-in EMI filter, ensuring that you'll get the adequate EMI performance on the power supply design, as well as effective decoupling between the payload modules. The mechanical design is being put in an AK style with built-in protection and decoupling while minimizing the pin count. This offers excellent thermal performance plus a proven flight heritage on the SA50 built in the SMT technology with isolated chassis and return pass. I show this design looking for further feedback from our customers on this solution size. Now, the current challenge with the SA50, we have some capabilities to improve the efficiency, offering faster performance, offering lower RDS on, as well as higher switching frequency. But the current efficiency downstream with the SA30 is approximately 72%. We're feeling that's not going to be quite enough to offer enough improvement to the market, so we're looking at ways to improve that overall efficiency. But as you can see, it's much more efficient than the current solution today with a lot of size benefits. The point of module offers you a simple power distribution solution. Here's kind of show you how we could put this together with the RTG4. It eliminates noise decoupling between the payload systems. It offers fault isolation and containment, a reduction in size, weight, and power. And the final implementation, we're looking at evolving this to hit more and more efficiency improvements. There's some extreme challenges with this as the power demands are increasing as the voltages are lowered, and we're having more and more dynamic current needs from the FPGA. So as I close, I was going to leave this to Brian to further go into our RTG4 power solutions.